This video was brought to you by the ILC. Hello there once again. Welcome to episode 33, Finding Horizontal Asymptotes and Intercepts of Rational Functions. In our previous episode, we found the vertical asymptotes and holes of a rational function. This time, we're going to learn how to get a little bit more information from a rational function. Let's get started. Our rational function this time is 4x squared minus 16 divided by x squared minus x minus 6. And our goal is to find the x-intercept and the y-intercept. Now we factored this down into simpler form in the previous episode, so I've written that here as well. 4 times x minus 2 times x plus 2 divided by x minus 3 times x plus 2. Recall that the x plus 2 represented a hole in the function. I'm going to go ahead and cross those out now and cancel them out. We are not going to need that for this part of the problem. Let's find the x-intercept first. So for the x-intercept, the first thing we want to do is set the numerator equal to 0. The numerator that we are going to use is the simplified one here with the whole canceled out, 4 times x minus 2. We'll set that equal to 0. Well, first thing let's do is divide by 4. Of course, 0 over 4 is still 0. And simply add 2 to both sides. So we'll have x equals 2. Of course, it's not enough just to get the x value. You need to write it as an ordered pair, which is 2, 0. We'll use this in our next episode when we graph the function. For now, let's move on to the y-intercept. For the y-intercept, we set x equal to 0. Again, let's use the simplified form that we have earlier. We'll have 4 times 0 minus 2 divided by 0 minus 3. Of course, 4 times negative 2 gives us negative 8, and 0 minus 3 gives us negative 3. Since they're both negative, we'll just call this 8/3. Of course, it's not good enough to write this as a single number. We have to write an ordered pair. So we'll have 0 and 8/3. And that's how you get the x-intercept and the y-intercept. Next, let's talk about how to get the horizontal asymptote of the function. To find the horizontal asymptote, we'll need to compare the powers in the numerator and the denominator. There are 3 different outcomes for this, and which outcome you see is going to dictate how to find the horizontal asymptote. Let's represent the power in the numerator as Pn and the power in the denominator as Pd. The power in the numerator could be greater than the power in the denominator, or it could be less than the power in the denominator, or they could be the same. Now, if the power in the numerator is greater than the power in the denominator, in that case you will have no horizontal asymptote. It won't exist. It is possible that you could have a diagonal asymptote. Now, we won't worry about that right now. I'll show you how to get that in a later episode. Let's move on to the next possibility. If the power in the numerator is less than the power in the denominator, you will have a horizontal asymptote, and it will automatically be at y equals 0. It'll just be a horizontal dotted line passing through y equals 0. Now, if they are the same power, that's when things get interesting, because you will need to divide the leading coefficients. In our case, we can see that the powers are exactly the same, x squared over x squared. So we'll just divide the coefficients. We've got 4 on the numerator, and looks like 1 on the denominator. So we'll say that our horizontal asymptote will be at y equals 4. And that's all there is to horizontal asymptotes. Come back next episode, and I'll show you how to draw a graph, and we'll tie all this information together. I'll see you then.